Today we are going to see some basic definition and derivation of elasticity. Definition of elasticity: the property by virtue of which material bodies regain their original dimensions, that is, size, shape, or both, after removal of deforming force is called elasticity. In simple words, we can say that if something that able to stretch and return to its original size or shape are called as elasticity. For example, I can say rubber band. If I take this and stretch it, it will come back to its original position. This is the simple example of elasticity. Now we are going to study about stress and strain. What is stress? Stress is defined as applied force, or we can say that elastic restoring force per unit cross-sectional area of a body. We can write that stress is equal to applied force upon area, that is elastic restoring force upon area. What is SI unit of stress? The SI unit of stress is Newton per meter square. Now, dimension of stress is -2. Okay. There are three types of stress. Three types of stress. First one, longitudinal or tensile stress. Second one, volume stress. Third one, shearing stress. Okay, now longitudinal stress. Simply we can say that change in length of a body. Suppose when I apply some force, then it changes its length of a body, such as wire, beam, etc. This is called as longitudinal stress or tensile stress. See, definition. When applied force or deforming force produces changes in length of a body, such as wire, beam, etc. This is called as longitudinal stress or tensile stress. Thus, longitudinal stress is equal to applied force upon area of cross section. That is, we can say that applied force means that is F, and area of cross section means A. Consider that as A. Now, F is equal to mg. A, cross section of area is pi r square. This is the derivation of longitudinal stress. Now, volume stress. Simply we can say that change in volume. Like longitudinal stress. In longitudinal we said that changes in length. In volume it is changes in volume. If some force is applied, then it changes in volume of a body. It is called as volume stress. Now definition. If a deforming force produces changes in volume for body, then it is called as volume stress. Okay, now here this V is original volume, and this dV is decrease in volume, and this V minus dV is final volume. Now this is original volume, and this is final volume. So now original volume minus final volume, we get one value. Now we do it. Original volume, that is outer, and final volume, that is inner position here. So what is original volume here? V. What is final? V minus dV. Now this minus and this plus and minus, plus V and minus we cancel, and we get here is dV. That is volume stress is equal to applied force upon area. Applied force we studied here, that is A, right? So we're going to put here A and this dV, and area is A, already we knew it. Now this A and A get cancelled, that is dV. This is the derivation of volume stress. Now shearing stress, same like longitudinal stress and volume stress. Shearing stress is simply we can say that change in shape. Now see, in longitudinal stress, when force is applied, we said that it will change in length of a body. In volume stress, it will change in the volume of a body. In shearing stress, if force is applied, then it will change in shape of a body. And for definition, if deforming force produces changes in shape of a body, then it is known as shearing stress. Now, strain. What is strain? Strain is defined as the change in dimension per unit original dimensions. Now, dimension of strain, that is strain is dimensionless. Strain has no dimension, and strain is a pure number. Therefore, strain has no unit. What is the unit of stress? Newton per meter square. But for strain, there is no unit because strain is a pure number. Same like stress, there are three types of strain. First one is longitudinal strain or tensile strain. Second one, volume strain, and last one is shearing strain. Longitudinal or tensile strain, that is defined as the ratio of change in length to the original length. In longitudinal stress, we studied the change in length to the cross-sectional per unit area. Here, the ratio of change in length to the original length, that is longitudinal strain is equal to change in length to the original length. That is, change in length means final length upon original length, final length minus original length upon original. See, final length is capital L plus small l, and original length is capital L. That is, final length is capital L plus small l minus original length is capital L upon original length is capital L, equal to, now capital plus L and capital minus L will get cancelled. Now small l upon L. This is the derivation of longitudinal strain or tensile. Now volume strain. Volume strain is defined as the ratio of change in volume to the original volume. That is, volume strain is equal to change in volume to the original volume. Okay, now volume strain is equal to change in volume upon original volume. See, this change in volume we had already derived in volume stress. Here, what is volume stress? If a deforming forces produce changes in volume of a body, changes in volume of a body, here changes in volume already we had derived, that is dV. So here changes in volume is equal to dV, and what is original volume is V. That's all. This is the derivation of volume of strain. Now negative sign. What does this negative sign means? This negative sign indicates that there is decrease in volume with increase in pressure by dP. But for numerical purpose, for numerically, we should not use this negative sign. So for numerically we say that volume strain is equal to dV upon V. Now shearing strain. If the applied force produces changes in shape of a body, that is from cube to parallelopipe, this is known as shearing strain. Okay, now Hooke's law. Robert Hooke from 1635 to 1703. He was an inventor, an astronomer and physicist from UK. He has given the fundamental law of elasticity. Stress versus strain curve for an elasticity. This is stress and here strain. Here the slope. This slope is said as modulus of elasticity. Statement. Within elastic limit, stress is directly proportional to strain. Thus, stress is equal to strain. Stress is equal to M strain into strain. This M is nothing but the constant of proportionality, M, which is called as modulus of elasticity. This is the slope of stress and strain is modulus of elasticity, that is M. Here. Now this M is equal to stress upon strain. That's all. This is Hooke's law. Thus, the modulus of elasticity of a material is defined as the shape of the stress and strain curve. This one, stress and strain curve. In elastic deformation region. Simply we can say that the modulus of elasticity of a material is the ratio of stress and strain. Ratio of stress to strain. In simple words, we can see this. Will be continue in next video. Hope you all understand. Thanks for watching. Please keep support. Subscribe to our channel. Like and share it with your friends. Thank you.